A'udhu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. Today we are going to talk about carbon nanotubes. Uh, this is actually connected with this lecture is connected with the last lecture, but the carbon nanotube is actually a vast topic, so therefore we have divided into two lectures. So today we will also discuss the synthesis, application and properties of the carbon nanotubes. Basically, carbon nanotubes is a tube-shaped material that is made of carbon, and it have the diameter measuring in nanometer scale. So carbon nanotubes are formed from essentially the graphite sheet, and the graphite layer appears somewhat like a rolled up continuous unbroken hexagonal mesh, and carbon molecules are at the apex of the hexagon. So the nanotubes are members of the fluorine structure family. So their name is derived from their long hollow structure with the walls formed by one atom thick sheet of carbon that is called as a graphene. So carbon nanotubes are discovered in 1952, and two scientists published papers in the Swiss Journal of Physical Chemistry showing their unique morphology for the graphitic carbon fibers that are in nanometer range, and its diameter is around 50 nanometer. So moreover, in 1979, some other scientist John presented evidence of carbon nanotube at the 14th Biennial Conference of Carbon at Penn State University. So moreover, the improvement were made in 1981 when a group of scientists published their results regarding the chemical and structural characterization of that particular carbon nanoparticles that are produced in a unique method, that is a thermocatalytic disproportionation of carbon monoxide. So moreover, in 1991, nanotube discovered in the result of our discharge, and as a result of the hard work made by the Japanese scientists. So we have different types of carbon nanotube regarding their structures. It is divided into two main types. One is called as a single wall nanotube, and another is called as multi-wall nanotubes. In case of single wall nanotubes, the diameter of this wall is around 1 nanometer, and the band gap, if you look toward the band structure, it has a band gap of around 0 to 2 electron volt, and one atom thick layer of graphene into seamless cylinders. Their electrical conductivity can show metallic or semiconductor behavior. This is the images of some of the single wall carbon nanotubes. Now we look toward the multi-wall carbon nanotubes. So in case of multi-wall carbon nanotubes, we have different layers or multiple layers, and these multiple layers are rolled layers of graphene. The interlayer distance in this particular case is around 3.4 angstrom. So moreover, there are different models presented to describe the structure of multi-wall carbon nanotube. So that is one Russian and one is our own model of the Persian models to describe the structure of this multi-wall carbon nanotubes. This is some of the information or the parameter describing the different structures of the carbon nanotube. We have different particular structure. The three famous are the armchair structures. This is the armchair structure of carbon nanotube, this one, and then we look toward the zigzag carbon nanotube structure, and there is chiral carbon nanotube structure. So we have different particular structure for the carbon nanotubes. So how we can describe these different structure from each other? If we compare in a single peak, it will be like the armchair that has the characteristic of metal. I mean, its properties are like a metal, and this is the structure of armchair carbon nanotube. The zigzag type has properties that change depending on the tube diameter. Depending on the tube diameter, we can tailor or we can engineer the property of the zigzag carbon nanotube. And the other is a spiral type of that particular carbon nanotubes, which have the properties, interesting properties of semiconductors. So properties of nanotubes, why these nanotubes are important to us and why it has wide range of application. Before discussing its wide range of application, we need to look towards its excellent properties. That is why it has attracted, it has been a useful material for wide range of applications. So if you look toward the strength of this material, then the carbon nanotubes are the strongest possible materials, and along with this strongest, it is stronger structure, it is flexible and stiffest material till yet. Moreover, it has high tensile strength and elastic modulus as well. If we look toward the hardness of this material and compare with some conventional material, then the hardness of if we see the hardness of a bulk hardness, this hardness is 152 gigapascal, and its bulk modulus is around 462 to 546 GPa of carbon nanotube. That is actually greater than a diamond's, so which is considered as the hardest material. If you look toward the electrical property, because of its application in electrical appliances, because of the symmetry and unique electronic structure of graphene, nanotube has a very high current carrying capacity. So looking toward the thermal conductivity, by using it to be in some specific application, the nanotubes are expected to have a good thermal conductors along the tube. So if we see toward the electromagnetic waves absorption capacity of these nanotubes, so there has been some research on filling multi-wall carbon nanotube with metals such as Fe, NiCO, etc. to increase the absorption effectiveness of multi-wall carbon nanotube in microwave regime. Looking toward the thermal property of these unique structures, the nanotubes are expected to be very good thermal conductors along the tube, but good insulator laterally to the tube axis. So it has very interesting property, because at some axis or in some places it is good conductor, but in some axis or some places it is acting like insulator. So this is the structure of the nanotubes, single wall carbon nanotube, and its diameter, its length to diameter ratio, or the aspect ratio, that is actually the ratio between the length to diameter for a particular carbon nanotube. This is especially for single wall carbon nanotube whose diameter is around 1.9 nanometer. So nanotubes have some the specific properties are mentioned here, and its values are mentioned, just like if you can see the current capacity, that is 1 gigaamperes per centimeter square. Similarly, if we consider the copper and compare the conductivity or the current capacity of copper, that is a good conductor and widely used in electronic industry, then its current capacity is only 1 milliampere per centimeter square. So looking toward the thermal conductivity, its thermal conductivity is comparable to pure diamond, that is 3320 W per m dot K. So the temperature stability of carbon nanotube is around 750 degrees centigrade in air. So metal was in microchips is 600 to 1000 degrees centigrade, and therefore it has also some interesting properties. So we want to elaborate some of the other elastic and plastic properties of the carbon nanotube with the help of this curve. We know that some of the materials have elastic deformation, that is actually the deformation which can be recovered back after the removal of external force, or the deformation of an object before the before the permanent or plastic deformation is called as elastic deformations. If we look toward the elastic properties and plastic property before the yield strength of that particular material, then the carbon nanotubes are known to be the strongest material, and its Young modulus is around 1250 GPa. For carbon nanotubes, if we consider the carbon fibers, is Young modulus is 425 GPa, and for the steel, if we compare the hardest material, or what we are considering to be a harder material, that is the steel, and we are using in daily life, its Young modulus is around 200 GPa. So if we compare its Young modulus with the Young modulus of carbon fibers or carbon nanotubes, so it's 3 to 4 fold greater than the Young modulus of carbon nanotube and carbon fibers is very much greater compared to the high strength steel. Looking toward the tensile strength of that materials, we see that in case of steel the tensile strength is only 2 gigapascal, but in case of carbon nanotube it can vary between 11 to 63 gigapascal. But if we look toward the carbon fibers, again it has very high tensile strength, and it is around 3.5 to 6 gigapascal, which is much higher than the tensile strength of the high strength steel. So elongation to failure is around 20 to 30%, and the density of carbon, the density is given as the carbon nanotube density, single wall carbon nanotube density is 1.33 to 1.4 gram per centimeter cube. If we compare with aluminium, it has the density of 2.7 gram per centimeter cube. So even it has low density. That is why it make it a very useful material for aerospace, because considering a very low density, it has very high Young modulus and tensile strength. So this is what we need in aerospace technology, that we need a material that is stronger enough and that has carry low weight. So here if we compare the strain and stress curve between the for this carbon for this particular material, then we have elastic region, plastic region, and finally it fracture. So elastic region is actually the recoverable region, or that is called as a elastic deformation is called as temporary deformation, which is the deformation occurred in a body before the after the application of force, and after the removal of force the body come back to its initial position. The plastic deformation is considered to be permanent deformation, which even after the removal of the force the body cannot come back to its initial position, and fracture occurs when the bodies separate from each other. So this is some of the examples or some images of the carbon nanotubes at different resolution. Here we can look towards this images or the structure of the carbon nanotube at 40 micrometers. Looking at the same material at high resolution, we can observe it at 8 micrometer, the same material. If we look toward the other material that is at 8 micrometers, it is further magnified, and at 1 micrometer we can easily observe the regular arrangement of these tubes along a specific directions. So this is another example where we can see the arrangement of the nanotube in different orders. So carbon nanotubes are also utilized in various type of application, as we have already discussed the synthesis and property of this material. So we can now look towards the application of this material. So it is widely used due to its attractive properties. It is widely used in various applications. Just like we have carbon nanotube light bulb filament that is alternative to tungsten filaments in incandescent lamps. So the average efficiency is 40% higher than that of the tungsten filament at the same temperatures. So it can improve its property with low cost. So moreover, the same material can be used, carbon nanotubes are used when a radio wave of specific frequency impinges on the nanotubes, it begins to vibrate vigorously. So an electric field applied to the nanotube forces electrons to be emitted from the strip. So this electrical current may be used to detect the mechanical vibration of the nanotube and thus listen to the radio waves. So this could be used as a type of radar in radar technology to create some current as a result of some microwave. So this is a type of detectors, but this is a specific detector of microwaves in the microwave regime, so that is specially used in radars. So if we look toward the application of the of this carbon nanotubes in electronics, so it is widely used in transistors, especially in field effect transistors. In this case, the active component of virtually all electronic devices are what we refer to as an electronic switching device. So especially in transistor, a small electric current can be used to control the on-off of that larger current. So this is also used, this carbon nanotube. Here we are looking in this that carbon nanotubes are arranged in a very regular pattern. So this could be used for very useful application in electronics, because a very small electrical current can be controlled with the help of some small switch, and that can control a large current. So along with the radars, light absorption capacity, and even in the last slide we discussed the in electronics, it is moreover used in semiconductor in some semiconducting devices as well, because we have semiconducting carbon nanotubes. As we discussed in the earlier slides, some of the arrangement of the carbon nanotubes have the semiconducting behavior. So we can also use the same material for various semiconducting application. Just like semiconducting carbon nanotubes has been used to fabricate field effect transistors. Just like in this case we have a special silicon gate and silicon oxide is grown on it. So there is a special drain electrode and source electrode that is used for this particular field effect transistors, and there is a nanotubes of molecules. So in this semiconductor, carbon nanotubes is used to fabricate field effect transistors. So the electron mean free path in the single wall carbon nanotube can exceed 1 micron, which is actually large. Therefore it is projected that carbon nanotube devices will operate in the frequency range of 100 of gigahertz. So the same carbon nanotubes are widely utilized in this is actually the field effect transistor. This is an image of field effect transistor, how it is developed and how it is utilized in various applications. So this is a same image of superconducting transistors, means the arrangement of that. So this is field effect transistor. So field effect transistors made from the carbon nanotubes are also utilized in electrically conductive materials. Just like carbon nanotubes can be electrically conductive, and due to their small diameter of several nanometers, they can be used as a field emitter with extremely high efficiency for field emission display. Just like we can use this for various type of display, and this principle of operation resembles that of the cathode ray tube, but on the much smaller scale. So looking toward the other application of these carbon nanotubes, we can see that a thin sheet made from the carbon nanotube that is around 250 times stronger than steel and 10 times lighter than that could be used as a heat sink for chipboards. So a backlight for LCD screen are as a Faraday's cage to protect the electrical devices. So this is one of the interesting application of carbon nanotubes where it is utilized. Carbon nanotubes are also utilized in hydrogen storage. We can use the carbon nanotubes that is made from different materials, especially the carbon nanotubes covered in titanium atoms provide a very efficient method for storing hydrogen. So the hydrogen that is created in water splitting or some other process that could be stored in some. So the carbon nanotubes could be used to store the hydrogen as well. So that is why it is widely used in such type of application. So artificial muscles made from nanotubes. The artificial muscle have been made from millions of carbon nanotubes. So it looks like natural muscles providing an electrical charge causes the individual fibers to expand and the whole structures to move. It is further used in nanoscale. So what is nanoscale? Nanoscale is actually a superconducting interferometer device. So SCID devices can be used to monitor infinitesimally small magnetic field or current. See, the originality of this work is to use the gate tunable carbon nanotube for the Josephson junction. So this is also used. So carbon nanotube can be used for the nanoscales. So the device combines features of a single electron transistor with typical properties of SCID interferometer. So this is one of the interesting application of carbon nanotube. So this is something what we discuss about carbon nanotube and various type of application of the carbon nanotubes. We will move toward the next topic in the upcoming lecture, inshallah. Thank you very much.